Hello and welcome to the second part of the tutorial on how to solve quadratic equations through factorization. If you haven't seen part 1, we would highly advise you to do so by clicking the link in the description. Now that we know how to factorize quadratic expressions, we can now move on to equations. Whenever you are trying to solve quadratic equations, the equation must equal 0. For the cross-factorization case, this is because we need to be able to divide one of the brackets and be left with a linear equation. If that sounds confusing, we will provide a couple examples to show why such a thing is important. Let's take the quadratic equation x squared plus 5x plus 6 equals 0. X squared separates into x and x, and 6 can separate into 2 and 3 to multiply together to equal 6, but also to add together to equal 5. This means we can factorize the equation into brackets x plus 3 close bracket multiplied by bracket x plus 2 close bracket equals 0. From basic multiplication, we know that in order for a number to equal 0, it must be multiplied by 0. That would mean that either x plus 3 equals 0 or x plus 2 equals 0. This is why we said that the equation had to equal 0. If instead the equation equaled 1, then we would not be able to move one of the brackets by division and be left with a linear equation, which simplifies the quadratic. Given that we cannot divide by 0, we must assume that one of the linear equations equals to 0. That will be the equation that is left over. If we assume that x plus 2 was equal to 0, then x would equal negative 2. Assuming that x plus 3 equals 0, we would have the answer negative 3, as we bring 3 to the other side of the equation after we divide 0 by x plus 2. As you can see, quadratics have a maximum of 2 possible answers. To summarize, the solution to the quadratic that we have just solved is either negative 3 or negative 2. Let's solve another quadratic equation. Take 2x squared plus 8x plus 6 equals 0. Splitting 2x squared into a and b would result in a being 2x and b being 1x. Through some trial and error, we can assign c to be 2 and d to be 3. The resulting middle term would be 2x times 3 plus x times 2, which equals exactly 8x. In the first bracket, we would have 2x plus 2, and in the second bracket, we would have x plus 3. Applying our method in the previous example, let's assume that 2x plus 2 equals 0. Thus, we would have 2x equals negative 2. Divide both sides by 2 and we would get x equals negative 1. Alternatively, x plus 3 could equal 0, which would give us the answer of x equals negative 3. Thus, we would have the two answers x equals negative 1 or x equals negative 3. Now that we've solved the quadratic, let's backtrack a little and see how we could have made the question slightly easier for us to cross-multiply. In the equation, we can see that all of them have the common factor of 2. Thus, we could have immediately divided by 2 to have the resulting quadratic being x squared plus 4x plus 3. This would make cross multiplication slightly easier as there are less factors to worry about. If we cross factorize, this would become much easier as a would equal x, B would equal x, and C would equal 3, and D would equal 1. We see that not only does it make cross-multiplying easier, but it also makes the resulting linear equations slightly simpler. The subsequent process is much the same as the process we have shown in the past examples. However, you might see a bit of a problem here. What if the right side isn't 0? Now, you are probably aware of the complications that would arise if it did not equal 0. However, like any other equation, we can manipulate it so that it equals 0. We take the example x squared plus 3x equals negative 2. We can plus 2 to both sides, which results in the equation x squared plus 3x plus 2 equals 0. A and B are once again both x. With 2 being a prime number, it can only be separated into 2 and 1. Thus, in the first bracket, we would have x plus 2, and in the second bracket, we would have x plus 1. Assuming that x plus 2 equals 0, we would have the solution negative 2. Assuming that x plus 1 equals 0, then we would have the solution negative 1. To summarize, for this specific quadratic equation, the solutions are negative 1 and negative 2. So congratulations, you've just learned how to factorize quadratics. That's all for today. Join us next week for our video completing the square. Please be sure to like and subscribe the video. So thanks for joining us, and bye for now.